We grab the sample, we segment it, and we do some extraction of the features. For example, for fingerprint, I might want to extract the minutia points. Most of you have probably seen CSI or the Discovery Channel, where you see a fingerprint and all of a sudden a bunch of red dots or orange dots are associated with some features on that fingerprint, and then they go run the search on that. That's called just feature extraction. We want to take a look at quality control as well to see whether that finger is of sufficient quality, that we've extracted all the correct features of it. We found in our research that the elderly, for example, have very poor quality fingerprints, and as a result, their performance may be a lot worse than regular individuals. Well, 18 to 62 is our group, and then 62 and older. And that's an issue because last time I checked, people who are old also traveled. They travel quite regularly. So if I put my finger on the sensor and it doesn't let me into the country, then that's going to be a problem. So we need to take a look at algorithms that look at extreme populations. And we do some work in the lab on that as well. If this is the first time you've been into interacted with the sensor, we create a template. That's basically a number of images, probably average. That, again, depends on the algorithm. And we store that in a database. We may store additional information. We either store the fingerprint, or we may store the fingerprint plus the PIN and some metadata as well. It all depends on your system. And then once you come back, you'll go through again, and we'll pull that template out of the database if we know who it is, and if not, we'll search through all of them. We'll get a match, and the match will give us a similarity score. And from that, the system will then make a determination whether to let you in or not. Right? So we get a threshold. That's kind of the hurdle, so to speak. And if the score is greater than the threshold, we'll let you in. And if it's less than the threshold, we won't let you in. That's typically how it works. Sometimes it's flipped, depending on the algorithm. Then we let you in, and then you do whatever. There's some errors associated with that. For example, we might not let you in when you're actually the genuine person, or we'll let you in when you're not the right person. And those errors are something that we want to minimize. And there's ways of doing that. One is to reduce the threshold, so you let everyone in. That's probably not a very good solution. Or the other way is to maybe choose a different biometric or fuse 2 or 3 biometrics together. There's software out there now that does lip, face, and voice. And then we can weight the different characteristic modalities depending on whether you have good characteristics in face, good characteristics in voice, or good characteristics with your lip movement. So there's plenty of ways of doing this. But this is the general biometric model. Any questions on this? Okay. Now, a typical question that I get all the time is, which one is the best biometric? We do a lot of implementations over in the College of Technology trying to figure out which one's the best biometric. And the best answer is, I'm not going to tell you, it's a big secret. The reason is because I don't know the best biometric. You can take a look at performance characteristics, in which iris looks pretty good in most of the curves that we present, and I'll show you them as well. But all biometrics have their strengths and weaknesses. One project that we're working on this semester is to secure the hangars out at the Purdue University airport. And we want to know what do we secure them with? Now, we may end up just securing them with an RFID card because throughput there is an issue. We need to get a batch of students through the door relatively quickly, about 50 students through one door in a fast period of time. And probably the best way maybe to do it is just with a simple prox card where you just walk through the door and it lets you in. With hand geometry, which may be what we end up using, it really depends, you've got maybe a 2-second throughput for each person. You've got to type your PIN in, stick your hand in. For face, you've got to look at the camera, which means no one else can be waving and doing silly stuff behind you, which we've had out there. So no biometric is really optimal. It really depends on your population and what they need to do or what their desire is to get through into that system. For example, if I want to claim some benefits and I'm using fingerprint recognition, I'm going to present my finger properly the first time because I need my money. Same at PEFQ's ATM. You're not going to put the wrong finger down. You're not going to move your finger around. Likelihood is that you want to get your money, you need it right away, and you'll put your finger and behave in the appropriate fashion. You want a particular outcome. However, if you don't want to be detected by face recognition in an airport, you'll likely put your head down. So we need to figure out the application that we're going to be using to figure out kind of the psychology of the user that we're doing. we have this project. Anyone, how many people go to the rec center? 1, 2, okay. Got a fit class here. All right. Well, the rest of you, if you do happen to go to the rec center and work out, there's a hand geometry reader on the front door. And you may have noticed it. Now, we have some gaming attempts where students will just go ahead and play with it, just to do it, which is fine, to interact with the device, make the lights go off, and there's no alarms or anything. There's absolutely no reward for playing with the device. But we find that several people a day will just play with it for you don't get into the system, it doesn't get you through the rec center any quicker than doing it normally. But we'll find some gaming attempts. And so that's kind of interesting to see how people interact with the device. When we had face recognition out at the airport, we found that people would go along and cover the webcams where we had face recognition because they didn't want to be on the cameras. And quite a lot of them were staff members that just didn't really want to be on the system. Now, we marked out on the ground, don't walk here. If you do walk here, you'll be actually captured. But you won't be verified or anything. We do that offline. But they could have walked around, but they just covered it up or moved the camera or did something like that. I was talking to a company in the UK this morning about doing some signature work, and we were collecting signatures, and they're like, well, actually, it's very interesting. We collected a whole ton of signatures in the lab, and we did some analysis of them and tuned our algorithm to these signatures, which is a logical thing to do. And then we took it out to the bank, and people signed differently when they were signing their mortgages. The signatures were a lot more serious because the documentation and the intent was a lot more serious than just signing their signature to get their $15 in the lab and to get out of there relatively quickly. So again, you have to assess your population, and each one of them will react. So let's go through some modalities. The first one is face recognition. It's probably the most common and used by humans. In the legacy systems, it's used in immigration just because every visa typically has a face associated with it. Applications run from mugshot verification. If you take 581, we have an armed robbery videotape, and we look at video quality and so forth, and we found that this video quality is extremely poor. We can't identify anyone, and they look at the camera, which is really quite disappointing. They see the camera, they look at it, they tell everyone else in their group that there's a camera. They all look at it, so you should be able to do some form of face recognition on it. Not the brightest characters. They look at it again, and they stare at it like, wow, there's the camera. And I don't think anyone's twigged that it might be recording anything. And then commit the robbery, look at the camera again, and then they destroy the camera. So you would have thought you destroy the camera first, then commit the robbery, but never mind. And so they tried to do some analysis of it. They sent it to our lab to see whether we could do some facial recognition because they were staring right at it. And I have my candidate list of individuals, my rogues gallery, and we couldn't do anything with the image at all because the video quality was so horrible. He kept on going over the VHS tape. He had the really ideal situation where everyone stared at the camera, but our face algorithms could not extract it very well because the image quality was so poor, because I don't think he changed the videotape since he installed the system. And he just kept overplaying. Now with DVRs and all of that stuff, that will get rectified, but that cost some money, and he just had a VHS tape. So that was kind of disappointing to us that an advanced face recognition algorithm couldn't figure it out, especially when you had such an ideal candidate set of people staring at it for seconds. It was very frustrating in the class as well. They're like, what's going on? Now, the other one, the more difficult one, is dynamic uncontrolled face verification, where I'm just walking around and I need to grab your face for whatever reason I want to do that. And one example would be in the subway system in London, where we see that we can capture your face as you walk through the system. It's uncontrolled. You're not looking at the camera, typically, and they're everywhere if you've ever been over there. We can do it two ways. We can do it based on location or shape of your face, looking at your lips, chin, and whatnot, or we can just take a generalized viewpoint of your face and go from there. In order for it to be successful, we need to detect whether a face is present. That may sound kind of redundant, but if you're standing by a domed window or a